Number 48 in Chapter 19 talks about a patient receiving a dose of radioactive iodine. It says that at 8 a.m. a patient receives a 58 milligram dose of iodine 131. They do this to obtain an image of their thyroid. This nucleotide here has a half-life equal to 8 days. And it says, or asks us, what mass of our I-131 remains at 5 p.m. the next day. So basically we're talking about kinetics here. We're talking about how we can relate half-life to our rate constant, little k, and then how that rate constant relates the number of molecules or things at any given time point. Remember, radioactive processes are always first order, and so that's why we use those first order expressions. And so one thing to figure out would be our time. If we take our time, our 8 a.m. and our 5 p.m. the next day, that's more than 24 hours. That's actually 33 hours. If we take the difference there, or if we then convert that into days, since our half-life is in days, that would be 1.375 days later, after we gave the patient the 58 milligrams of iodine 131. So we first need to solve for our K, and then once we have our K, we can substitute that into our first order expression and solve for N sub T, which is going to be that mass of iodine 131 that's still left in the system. So if we rearrange our half-life expression, we can say that our K is going to be 0.693 over our half-life, right? Or 0.693 over 8 days. And so our K is equal to 0.0866. And so that would be days to the minus 1, or reciprocal days. And now we can use that to plug it into our expression for number 2. So we solved for the first part of this. Now let's get to the second part. Again, we want to rearrange it. And so if we take e to the both sides and then solve for n sub t, we would get our n sub t would be equal to e to the negative kt, that quantity times that initial value. So that would be e to the negative 0.0866 times 1.375, which is our time, 1.375 days later. And then that whole value would be multiplied by our 58 milligrams, or that our initial value. And so if we continue down that calculation, we should get 0.8877 for the E value. We're multiplying that by 58, and so we would have 51.48 milligrams of that iodine 131 remaining in that patient's system or body. That is number 48 in Chapter 19.